demonstrating performance benefits of human swarm teaming. Humans and robot swarms each have different advantages and disadvantages. Humans tend to be more versatile, while robots are specialized. Humans have superior critical thinking and can generally be trusted more and can explain their actions if required. On the flip side, humans often form a single point of failure and can't cope with a huge amount of information, whereas robots can distribute the processing required and generally react much faster and cope better with high workload. The intention of human swarm teaming is to combine these two approaches such that we gain the collective advantages of each one, pursuing a more powerful combined team. To demonstrate this, we extend the Harris multi-agent simulator. This is a swarm robotics simulator with live, constant human interaction at the core. It features a Google Maps interface, so we can model a real-world location, and in this case we're modeling a search and rescue scenario where agents are going to search for casualties on Southampton Common. They're going to move towards them and try and find out whether they are actual casualties or false positives. To reduce the burden on the user, we employ the maxsum algorithm for autonomous allocation. This allows the swarm to autonomously assign itself and reassign itself without a direct requirement for human input. As an agent approaches a potential casualty, the user can investigate a simulated image scan which is shown live to the user. Each target can be classified either as a casualty or not a casualty, depending on what is seen, or the human can leave it up to the agent to classify it when it gets there. This approach for including the human in the swarm system essentially has them form part of the decision-making process, not the allocation, leaving the simpler task of allocating agents to resources to the swarm itself. In doing so, we reduce the human's cognitive workload. They're not rushed and they're not overloaded. They can always slow down or pause if they need to. The swarm will continue to complete the task without the human's help, but a human is able to empower the swarm, and in doing so, allows certain targets to be classified sooner by using the advantages that the human alone presents to the swarm system. In summary, the Harris simulator facilitates quick and easy human swarm experimentation. We propose that a combined human swarm team will perform better than a fully autonomous one. And by including the human in the classification process, it may be a more interesting and powerful approach than having them try to manually operate the swarm.